Alrighty, today we are looking at the Hinge Theorem. And so the Hinge Theorem is a special theorem that has a lot of great applications within a triangle. So today our big thing is that we just want to be able to apply the Hinge Theorem and to be able to compare information about triangles. It's a really good thing for being able to compare and contrast what you have in a triangle. So definition of the Hinge Theorem, or just basically what the Hinge Theorem says, is it says that if you have two sides of one triangle are congruent to the corresponding, so the same two sides of a second triangle, but the included angles are not congruent, then that third side is going to be larger. Then the third side of the triangle with the larger included angle will be longer. So basically, I've summed it up here, and this is the best way that I can kind of sum it up here is the bigger the angle, the bigger the side. So that's basically what the Hinge theorem is saying. So two sides that are congruent in two triangles, but the angle is a different measure. The bigger the angle, the bigger the side. Or you can go vice versa. The bigger the side, the bigger the angle. So in this case here, it says which side is longer, AC or DF. And so basically what we're looking at is we're looking at AC right here, and then we are looking at DF right here. So those are our sides that we're looking at. And so we have to look at this. Now, we just have to compare the angle measures. So the measure of angle B is going to be 42 degrees. And then the measure of angle E is 36 degrees. So this one here is bigger, which means that the side that's opposite of this is going to be the bigger side. So angle B right here, that is going to be the bigger side. So I would say that AC is going to be bigger. That's the one that would be the bigger or the longer side. That's all that Hinge theorem is. So a couple more examples here. Now, this is just kind of the reverse of it, or the converse of it, and that's just saying that which angle measure is going to be smaller. So in this case here, we're looking for smaller. So we're still going to use the same thing, bigger the side, the bigger the angle, or the bigger the angle, the bigger the side. But now we're looking at which one's smaller. So again, we've got angle A is going to be right here, and then we've got angle D is going to be right here. And so what we have to do is we have to look at what's across. And so when I look at that, the angle that's across, or the side that's across from angle D is going to be 15 feet. And then the angle A, the side that's across from that, is going to be 18 feet. So this one here is going to be bigger, which means angle A is going to be bigger. Well, again, make sure you're answering the question here. It says which angle is smaller. So if this one's going to be bigger, I would say that angle D would be my answer, because that one is going to end up being smaller than angle A. All right. Last one that we have here, and this is just kind of a broad application of the Hinge theorem, but it's saying what is a possible length of DF? Now, this is not asking you for an exact answer, because it's impossible to be able to do that with the limited information that we have. But what we can do is we can think about what the actual thing is going to end up being, what the actual length might end up being. So what we have here is we've got angle B is 42 degrees, and then we've got angle E is 85 degrees. And so if we look at these that are across, that's the sides that we're looking at. So AC is going to be across from angle B. Well, the measure of angle B is that 42 degrees, which that's smaller than the measure of angle E. Measure of angle E is 85 degrees. So because of that, I know that this side here, the side that's across from it, has to be smaller than DF. Well, if it's going to be smaller than DF, then I need to find a number that's bigger than this. So like if I wrote down 8 centimeters and maybe 16 centimeters, and then we'll say 28 centimeters, if those were my possible answer choices, I can already look at this and I can say, well, hey, it's not going to be 8 because that's smaller. So I don't want one that's a smaller side than that. And then I can also cross off the 16 because that's equal. And if they're equal to each other, then that means that the angles would have to be equal as well. So same side, same angle that you have there. So it's not going to be either one of those. The correct answer in this case here would end up being 28 centimeters. So that would be a possible side length for DF.